Good morning, all of you. In this session, I'm going to explain about these two problems. Okay? These two problems related to friction problems. Okay? In this session, I will explain how to determine coefficient of friction and tension in the strings. These are the two example problems I will discuss. Now coming to the first example, this is the given question. This is a given diagram. Okay, a body of weight 15 newtons is resting on a rough inclined plane. As shown in figure. The body is tied up by a horizontal string. Which has a tension of 5 newtons. Okay, find the frictional force on the body, normal reaction of the inclined plane, and the coefficient of friction between the surfaces of contact. Okay, this is the question. From this question, first of all, you have to identify the given values. Okay, here the self weight of the block is given, that is W equal to 15 newtons. Okay, the self weight of a block W equal to 15 newtons. And the tension in the string is given. So already we know that the tension always acts like this along the string. Okay, this is tension T. The value of T, tension T in the string, T equal to 5 newtons. Okay, so the tension in the string is T equal to 5 newtons and the self weight of a block W equal to 15 newtons. Okay, now by using these two values, you have to determine the frictional force. Frictional force here, the direction of motion of a block is downward direction. So you have to consider frictional force. Yeah, this is a frictional force direction. So you have to consider friction between the block and plane, F equal to mu r, and the normal reaction in the normal reaction of the plane. So yeah, the reaction always makes an angle 90 degrees with respect to the plane. Okay, this is a reaction force R. Okay, and the coefficient of friction between the surface and contact. That means already we know that friction force F equal to mu r. So from this equation, you have to determine mu. Okay. So in this question, you have to determine the normal reaction R and the frictional force and coefficient of friction mu. Okay. So the given values are self weight of your body W equal to 15 newtons and tension in the string T equal to 5 newtons. Okay. Here you have to determine the value of normal reaction R, normal to the inclined plane, coefficient of friction mu between the block and the plane, frictional force between the block and plane, F equal to mu r. Okay. So here capital R, capital mu, and mu r. You have to determine the value of F, R, mu. You have to determine these three values. Here the angle of inclination of the plane is given, that is alpha equal to 45 degrees. Okay. Now you have to consider the given diagram. Now you have to convert this given diagram into free body diagram. Okay. So here, this is a tension. Here, the tension, already we know that tension always induced in the string, in the direction of string. So here, this string is in horizontal, so horizontal position. So you have to consider horizontal tension. The value of tension T equal 5 newtons already given in question. So you have to consider a tension value T equal to 5 newtons. Okay. And this tension makes an angle 45 degrees with respect to this reference plane. Okay, 45 degrees with respect to the parallel axis. Now, this is the direction of motion of the block. Okay, so this block moves downward. So this is a given inclined plane. Okay, this is a given block of weight W equal to 15 newtons. Already we know that the self weight of a body always acts vertically downwards. Okay, this is the self weight of a body W equal to 15 newtons, always acts vertically downwards. Okay, this self weight of a body W makes an angle alpha with respect to the vertical axis. Okay, this is the angle of inclination of the self weight. Okay, alpha. And this is the normal reaction. Already we know that normal reaction always makes an angle 90 degrees with respect to the given surface. Okay, and here the direction of motion of the block is downward. So you have to consider a opposite frictional force. Here, this is the friction force. Okay, already we know that this friction force always acts opposite to the direction of motion of the block. Here, the direction of motion of the block is downward. So you have to consider upward frictional force. Okay. Now, this is a given tension T, horizontal tension T. Now you have to convert this W and tension T into parallel and normal components. Okay. These are the two reference axes. This is parallel to the inclined plane. This one is normal to the inclined plane. Okay. Now you have to convert this W 15 newtons into normal component and parallel component. Okay. So here you can observe this W self weight makes an angle alpha with respect to this normal axis. So you have to consider W cos alpha along the normal axis and W sin alpha along the parallel axis. Okay, these two are the components for self weight W. So here I converted this W self weight into two components. Okay, normal to the plane and parallel to the plane. Okay. After that, you have to draw this normal reaction as it is. Now you have to consider this friction force as it is. Now you have to convert this tension in the string T into two components, that is along the inclined plane and normal to the plane. Okay, here this tension force makes an angle alpha from the given diagram. This tension T equal 5 newtons makes an angle 45 degrees with respect to parallel axis. Okay, so this tension makes an angle alpha with respect to this parallel axis. So you have to consider cos T cos alpha along the parallel axis, T sin alpha along the normal axis. Okay, T cos alpha, T sin alpha. These two are the components for tension. Okay, so this is the final free body diagram for this problem. Okay, now you have to consider this free body diagram for determining the value of coefficient of friction. Okay, now this is the free body diagram. From this free body diagram, you have to observe the weight W equal to 15 newtons, tension T equal to 5 newtons. For determining the value of reaction force R, you have to resolve all the forces along the normal plane. Now you have to consider sum of all vertical forces along the normal plane. So here you have to consider for upward action, you have to consider positive sign. For downward action, you have to consider negative sign. Okay, here this one plus R minus W cos alpha minus T sin 45 equal to 0. Here alpha equal to 45 degrees. Okay, now from this equation, reaction force R equal to 15 cos 45 plus 5 sin 45. Here W equal to 15 newtons and T equal to 5 newtons. Okay, so the normal reaction R equal to 14.14 newtons. Okay, the value of normal reaction R equal to 14.14 newtons. Okay. After getting the normal reaction, you have to determine the value of coefficient of friction mu. For determining the value of friction, you have to resolve all the forces along the parallel plane. Now consider sum of all horizontal forces equal to 0. Here for right side direction, you have to consider positive sign. For left side direction, you have to consider negative sign. Okay. So here these two are the right side direction forces. So you have to consider positive sign for these two forces. For this force, you have to consider negative sign. Okay. So plus T cos 45 plus mu r minus W sin alpha equal to 0. Okay. For right side direction, you have to consider positive sign. For left side direction, you have to consider negative sign. Okay. From this equation, coefficient of friction mu into normal reaction R equal to W sin alpha minus T cos 45. Okay, mu R is the frictional force. Frictional force F equal to mu R equal to 7.07 newtons. Okay, this is the value of a frictional force between the block and plane. Okay, after getting the frictional force, you have to determine the value of coefficient of friction mu. From this equation, the coefficient of friction mu equal to frictional force divided by reaction force. Okay, already we know the value of friction force and the normal reaction. Substitute these values in this equation. Finally, you can get the value of coefficient of friction between the block and plane. Mu equal to 7.07 divided by 14.14 equal to 0.5. Okay, the value of coefficient of friction mu equal to 0.5. Okay, already we know that there is no units for coefficient of friction. Okay, no units for coefficient of friction. Okay, this is a final answer for this problem. Okay, now coming to the another problem. This is a given question. This is a diagram, given diagram. Okay, from the given question, first of all, you have to identify the given values. Okay, a cord or string connects two bodies of weights 400 newtons and 800 newtons. Okay, the two bodies are placed on a rough inclined plane, and cord is connected parallel to the inclined plane. Okay, the coefficient of friction between the block 400 newtons and the plane is 0.15, and the coefficient of friction between the block 800 newtons and the plane is 0.4. Now determine the inclination of the plane to the horizontal, and the tension in the cord or tension in the string when the motion is about to take place downward the inclined plane, down the inclined plane. Okay, the body of weighing 400 newtons is below the body of weight 800 newtons. Okay, this is the given question. From this given question, the given values are self weight of your body 1 W1 equal 400 newtons, and self weight of your body 2 is W2 equal to 800 newtons. And here let R equal to normal reaction. R1 is the normal reaction between the block 400 and the plane. R2 is the normal reaction between the block 800 and the plane. Okay. Coefficient of friction for 400 newtons body. Yeah, the value of coefficient of friction between the body 400 newtons and the plane is 0.15, and the coefficient of friction between the block 800 newtons and plane is 0.4. Yeah, the friction force F1, that is the friction force in between block 400 newtons and plane is F1 equal to mu one R1, and the friction force between the block 800 newtons and the plane is F2 equal to mu2 R2. Okay. Here the angle of inclination of the plane is alpha. From this from these details, you have to determine the angle of inclination of the plane. Okay. From this diagram, you have to determine a angle of inclination alpha. Okay, with respect to horizontal plane. Okay, from this diagram, you can observe a cord or string connects two bodies of weights 400 newtons and 800 newtons. Okay, there is no external force, there is no pulling force. Okay, pulling or pushing force. Okay, there is no external forces. Okay, now you have to consider this diagram. Now you have to consider this problem as a freely falling body. Okay, that means there is no action force acting on the body. Okay, then the direction of motion of the block is downward, down the plane. Okay, from the given diagram, first of all you have to draw free body diagram for each block. Okay, here capital T is the tension in the string. Okay, already we know that the tension or tensile force induced in the string is T, capital T. Okay, now you have to consider parallel reference line and normal reference line. Okay, this line parallel to the inclined plane, this line normal to the inclined plane. Okay, now you have to consider self weight 400 newtons vertically downwards. Okay, already we know that self weight of any body acts vertically downwards. Okay, so W1 equal to 400 newtons. After that, you have to consider normal reaction at point of contact. Here you have to consider normal reaction. Now these are also reference axis for block 2. This is the direction of a self weight W2 equal to 800 newtons for second block. Okay, this is the normal reaction between the block 400 newtons and the inclined plane is R1. Always this normal reaction makes an angle 90 degrees with respect to the inclined plane. Okay, now you have to consider reaction force between the block 800 newtons and the inclined plane is R2. Okay, R2 is the reaction force between this block and inclined plane. Okay, now this is a tension or tensile forces induced in the string. Okay, if you are considering this block, you have to consider tension in upward action. When you are considering this 800 newtons block, then you have to consider left side tension. Okay, now let's consider the direction of motion of the block. Okay, so this is the direction of motion of the block. Now you have to consider opposite frictional force. Okay, this is the frictional force between the block 400 newtons and plane. Okay, already we know that friction force always acts parallel to the reference plane. Okay, parallel to the support and also opposite to the direction of the motion of the block. Okay, always you have to consider friction force opposite to the direction of motion. Okay, here the direction of motion of the block is downward, so you have to consider upward friction force. Okay, now you have to consider this second block. This block also moves downward, so you have to consider upward frictional force. Now these two are the frictional forces. Okay, this one is F1, this one is F2. Okay, F1 is the frictional force between the block 1 and inclined plane, and F2 is the frictional force between the block 2 and plane. Okay, now by using given details, you have to determine the value of tension T and angle of inclination of the plane alpha. Okay, from given details, you have to determine tension T and angle of inclination alpha. Okay, here the value of mu1 equal to 0.15 and the value of mu2 equal to 0.4. Mu is the coefficient of friction between the block and plane. Okay, now you have to consider this body or this block. Okay, you have to consider first block as a case 1. Consider the equilibrium of a block of weight W1 equal to 400 newtons. Okay, now you have to consider two reference axes. This axis parallel to the inclined plane, this axis normal to the inclined plane. Okay, now you have to consider self weight of the body. Okay, here the self weight of this block is 400 newtons. Already we know that self weight of any body acts vertically downwards. Now you have to consider reaction force, normal reaction force. This normal reaction force makes an angle 90 degrees with respect to the support. After that, you have to consider tension in the string or tension in the cord. Okay. Now the direction of motion of the block is downward. So you have to consider upward frictional force, opposite frictional force. Here the motion of the block is downward. So you have to consider upward direction for friction. Okay. So already we know that the direction of a friction force opposite to the direction of motion. Okay, it is very important. Now these all are the forces acting on the block. Now you have to draw free body diagram. Here W equal to 400 newtons, alpha we don't know. The value of alpha you have to find out that value. And R1 is the normal reaction force, and mu1 is the friction force between the block and the plane is 0.15. Okay, the tension in the string already we don't, that one also we don't know. You have to find out that value. And R1 also you have to determine friction force F equal to mu1 R1. Okay. Now you have to consider two reference axes. Okay, this reference axis parallel to the inclined plane. This reference axis normal to the inclined plane. Now you have to consider these forces here. First of all, you have to convert this 400 newtons self weight into two components. Okay, from this figure you can observe this self weight 400 newtons makes an angle alpha with respect to what, with respect to normal axis, normal reference line. Okay, so first of all you have to convert this 400 newtons into two components, that is along the normal plane and along the parallel plane. Okay, already we know that 400 cos alpha is the normal component and 400 sin alpha is the parallel component. Okay, this self weight 400 newtons makes an angle alpha with respect to normal axis. So you have to consider cos alpha. Okay, cos alpha. This alpha is adjacent side. For adjacent sides, you have to consider cos alpha. For opposite sides, you have to consider sin alpha. Okay. Here I converted this 400 newtons into two components, 400 cos alpha and 400 sin alpha. Okay. After that, you have to consider this normal reaction as it is. Okay. Now you have to consider this tension force and the frictional force as it is. These two forces are lies on parallel axis or inclined plane. Okay, tension and friction force, these two forces lies on inclined plane. So you have to consider this inclined plane. Okay, now this is the free body diagram for this condition. Okay, free body diagram of a block of weight 400 newtons. Okay, now for determining the value of reaction force R1, you have to resolve all the forces along the normal plane. Okay, for determining the value of determining the value of tension T, you have to resolve all the forces along the inclined plane. Okay, in first step, I consider all forces along the normal plane. Resolve all the forces along the normal plane. Here R1 and 400 cos alpha, these two are the forces lies on the normal plane. So for upward action, you have to consider positive sign. For downward action, you have to consider negative sign. So plus R1 minus 400 cos alpha equal to 0. Okay, for upward action, you have to consider positive sign. For downward direction, you have to consider minus sign. Okay. From this equation, R1 reaction force R1 equal to 400 cos alpha. Okay. This is the value of normal reaction between the block and plane. Okay. After getting the normal reaction, you have to resolve all the forces along the inclined plane. Okay. That is the sum of all horizontal forces. Here, these three are the forces lies on the parallel plane. Okay. Here, for right side direction, you have to consider positive sign. For left side direction, you have to consider negative sign. Okay. For upward action, plus t minus 400 sin alpha plus mu1 r1. Okay. Now you have to substitute the value of r1 in this equation. Then you will get the value of tension T. Okay. The tension in the string T equal to 400 sin alpha minus 60 cos alpha. Okay. This is equation number 1. Now consider free body diagram of a block of weight 800 newtons. Okay. Let's consider a second block 800 newtons. Now you have to consider free body diagram for this block. Okay. Now these are the two reference axes. One is parallel to the inclined plane, other one is normal to the inclined plane. Now you have to consider self weight of 800 newtons vertically downwards. Okay, self weight always acts vertically downwards. This self weight makes an angle alpha with respect to the normal axis. Okay. Now R2 is the normal reaction between the block and plane. T is the tension in the cord or tension in the string. Okay. Now the direction of motion of this block is downward, so you have to consider upward frictional force. Okay. This is the direction of motion. You have to consider opposite frictional force. Okay. This is the direction of a frictional force. Friction force always opposite to the direction of motion. Okay. Now here W equal to 800 newtons. Okay, alpha, you have to find out the value of inclination of the plane, alpha, and coefficient of friction between the block 800 newtons. 800 newtons body, mu t equal to 0.4, mu t equal to 0.4, and tension in the string or tension in the cord equal to T. Okay, already we know that the equation T. Normal reaction R2. Normal reaction between the block and plane is R2. Friction force between the block and plane is F2 equal to mu to R2. From these details, you have to determine the value of R2 and T. Okay. For determining the value of R2, you have to consider all forces along the normal plane. For determine the value of tension T, you have to consider all forces along the parallel plane. Okay. First of all, you have to convert this inclined force W into two components. These are the two reference axes. This one is parallel to the inclined plane. This one is normal to the inclined plane. First of all, you have to consider this self weight 800 newtons. Okay. You have to already we can observe this self weight makes an angle alpha with respect to this normal axis. So you have to convert this self weight 800 newtons into two components, that is parallel to the inclined plane and normal to the inclined plane. Okay. 800 cos alpha and this one is 800 sin alpha. Okay, here this is adjacent side, this one is opposite side. For adjacent sides, you have to consider cos alpha. For opposite sides, you have to consider sin alpha. Okay. Here I converted this 800 newtons force into two components. Okay. One is parallel to the inclined plane, other one is normal to the inclined plane. Okay. After that, you have to consider this reaction force as it is. Okay. Now you have to consider this tension. Okay, tension in downward direction. Now already we know that the direction of motion of the block is downward, so you have to consider upward frictional force. Okay. Now this is the free body diagram for this second case. For determining the value of reaction force R2, you have to resolve all the forces normal to the plane. For upward action, you have to consider positive sign. For downward action, you have to consider negative sign. So plus R2 minus 800 cos alpha equal to 0. So R2 equal to 800 cos alpha. Reaction force R2 equal to 800 cos alpha. This is the value of reaction force between the block and plane. Okay. For determining the value of tension T, you have to resolve all the forces along the parallel plane. Okay. So sum of all horizontal forces equal to 0. Here for right side action, you have to consider positive sign. For the left side action, you have to consider negative sign. So plus mu 2 R2 minus T minus 800 sin alpha equal to 0. Now you have to substitute the value of R2 in this equation. Then you will get the value of tension T. Here the tension in the string T equal to 320 cos alpha minus 800 sin alpha. That is equation number 2. Here the angle of inclination alpha is not given. So you have to determine the value of alpha from equation 1 and equation 2. Okay, from equation 1, the tension in the string T equal 400 sin alpha minus 60 cos alpha. From equation number 2, the tension in the string equal to 320 cos alpha minus 800 sin alpha. Now equating the values of tension T given by equation 1, equation 2. So this is equation number 1, this is equation number 2. Okay. 400 sin alpha plus 800 sin alpha equal to 320 cos alpha plus 60 cos alpha. Take sin alpha as common and here take cos alpha as common. From this equation, sin alpha by cos alpha equal to 380 by 1200. Already we know that sin alpha by cos alpha equal to tan alpha equal to 0.3166. Okay. The value of 380 by 1200 is 0.3166. Okay. Now after that, alpha equal to tan inverse of 0.3166. That value equal to alpha equal to 17.56 degrees. This is the angle of inclination of the plane with respect to horizontal plane. Okay. Now from equation 1 or equation number 2, from equation 1 or equation number 2, you can get the value of potential T. Okay. You have to substitute the value of alpha in equation number 1 or equation number 2. Then you will get the value of tension in the string. Okay. Tension T equals 63.4 newtons, 48 newtons. Okay. 63.48 newtons. So this is the final answer for this problem. Okay. In this problem, two bodies are in or